We are definitely in the biotech revolution. We're really discovering this new universe, not just conquer the world, but like conquer ourselves, really understand ourselves, right? I don't believe that there's going to be one pill that all of a sudden is just going to make us younger, right? I think if you really want to do a good management of longevity, you need data.
Dr. Maria Dunford is transforming the future of medicine, connecting the world's most valuable yet hardest to reach data. As founder and CEO of LifeBit, she's pioneering a data-driven era in healthcare, building platforms that power global precision medicine projects. Her mission: to unlock life-saving insights and make them accessible to those who need them most. From AI to big data, Maria is reshaping what's possible in genomics and laying the foundation for a healthier, more connected world.
In every cell of our body, we have a small universe. We can actually use a lot of computational and data methods to really try to understand and explore that universe that we have in every cell of our body. We will be able to have so much data from you from basically the time you're born. You will have basically a digital twin so that you never develop a disease in the first place. The second big problem or challenge that a lot of times companies face is how good are you at fundraising? Turns out that I'm somehow good at it. I had this kind of like superpower. It was not really being utilized. It was important for me to actually do something with that gift. And this is moving healthcare pretty much from symptom-based to data-based. I see a future where it will become data-based and almost not at all symptom-based. Our system is generic, right? So on that generalization, we also give you a pill that is supposed to work the same for you as it's supposed to work for me and everyone else on planet Earth. Well, that's not the truth.
Welcome, Maria, to the HumanWare Project podcast.
Thank you, Méline, for having me. I'm so excited to be here.
You are the founder and the CEO of LifeBit. Could you tell us what is LifeBit?
So LifeBit is now the largest provider of clinical and DNA data across the world. We have 270 million patients. And alongside the data, we do provide the software to make this data usable, effectively provide access and analysis to this data. We work with biopharmaceutical companies that need to have access to this data to be able to use this data for drug development and discovery. And on the other hand, we work with public sectors, the generators of a lot of this data through all of the different precision medicine programs that they do, as well as other for-profit data providers, 23andMe or Flatiron, some of our most notable clients, among many others.
What is the purpose and the mission of LifeBit?
So it's a very simple purpose. We want to make sure that any and all data that can be used to prevent and cure disease, it is actually used. I'm a computer scientist by training that eventually turned to a bioinformatics engineer, which eventually turned into a biomedical researcher. And then eventually I became an entrepreneur and I created LifeBit alongside my co-founder, Pablo. What led to the creation of the company when we were doing our PhD research, our job was to develop data analytics and computational methods to make sense out of this data. And soon enough, we found ourselves basically spending more than 80% of our time on the computational and data management hassles rather than actually the biology and the results of it. And at that point, we engineered a bunch of different solutions that we made obviously open source because they were part of our research. And those became extremely popular. And soon enough, we found ourselves in big demand from both the academic world, but also the industry, where they wanted us to come and consult because now they were getting more and more of the same data. Many years back, like only 10, 12 big institutes in the world had this type of big data. That was the point where we decided to create LifeBit, because we have created some of the most used, let's say, things at that point. So we knew that there wasn't good technologies out there. We knew there was a really big lack, especially if this was going to become the world reality and you're going to have so many different organizations generating this data at scale and wanting to be using this data for both diagnostic and drug discovery purposes.
What inspired you to get into biology and data and engineering?
So from when I was very, very little, I always loved challenges and hard problems. And I was finding myself like looking up at the stars and just like, swearing that I'm going to become like an astronaut or astrophysicist or something in between those. It wasn't until secondary school that I started actually realizing that in every cell of our body, we have a small universe.
Yeah.
And instead of needing to build big rocket ships and spend an entire lifetime in order to be able to like explore it, we can actually build different experiments, biological experiments. And later on, I started actually realizing that we don't even need to do biological experiments per se. We can actually use a lot of computational and data methods to really try to understand and explore that universe that we have, as I said, in every cell of our body. So that was the point where I really fell in love with biology and later on with bioinformatics. And that's what I started to do. But to be honest, it wasn't up until like later on in life when my grandfather was diagnosed with terminal cancer, kidney cancer. And I'll never forget the moment where kind of like, the doctors gave us the news and of course we're all crying. I felt this thing that out of everyone in that room, I was actually understanding more than anyone what cancer was, what was causing it. And I had this kind of like superpower. It was not really being utilized.
Yeah.
And I would say that was the change for me from like biology and biomedicine being a fascination to actually becoming like a true mission, where it was important for me to actually do something with that gift, right? And all of the studies and everything I had done up until that point. And it was eventually what led to LifeBit and everything that we're doing now at LifeBit and everything we're going to be doing, we're planning to do basically in the future.
It's quite incredible how ahead of everybody you decided to go to the route of collecting data and building the platform for that. When you started, it's not as obvious as today how important the data is. Can you tell us a little bit about the startup story of LifeBit? What are the biggest challenges you have faced creating this company?
So we started from Techstars, which is one of the world's best technology accelerators. I still mention Max Kelly, who was the managing director at that point at Techstars. He really gave me the opportunity. And as I always like to say, when we entered Techstars, we were just ambitious project. I wouldn't say we're yet a company. And it wasn't up until we actually completed Techstars 3 months later that we really became a company, right? So the first challenge was definitely both me and my co-founder, our background is very similar. Computer scientists turned to biomedical researchers and then eventually trying to become entrepreneurs. So definitely the first challenge that Techstars was really, really good at training us was just like, how do you get all of that startup training? So after graduating Techstars, we had to really learn get money in the business. One of my superpowers as well, being extremely good at fundraising. So 3 months later, we had fundraised the first seed round, 3 million in the bank. What followed that about a year and a half, 2 years later was a $10 million round. And then a year after that, a $60 million round with Tiger. And I'm mentioning this thing because I think that the second big problem or challenge that a lot of times companies face is how good are you at fundraising? How good are you at conveying that vision to the different investors that need to back you? And definitely that was a big learning experience, especially for me that was out there doing that. But as I said, turns out that I'm somehow good at it. I mean, the next big challenge was trying to get that product market fit, right? We had a vision with Pablo, and when we started this, we were building this technology, which at that point we were calling a cloud operating system, where basically was built in the simple thesis that once all of these organizations start generating all of this data from different patients, these are going to be big data, number one, but more important, there's going to be very sensitive data. So you will need to keep this data in place, and then therefore these organizations will create different cloud-based, mainly data centers, because they also need to be very scalable to be able to deal with the size and the computational load that's required for this data. And then about 8 months into the company, we had started engaging with some pharma to try to actually do co-development projects, because of course we hadn't yet finished developing the product, but at least to do co-development projects so that we can understand what are their needs. And we had this very dramatic board meeting where pretty much we coming back and we're saying, hey, the entire pharma has basically very little human data, right? None of them is actually in cloud. At least they're not using cloud for analysis of such data. It was a very, given time, everything becomes a comedy. But at that point in time, my board was just like, okay, can we just do a very shallow copycat of other existing solutions type of platform and just please call it a day. And we basically said no to that, and we stuck to our guns. And our board supported us eventually, because we said, like, we need just to take this risk. We need to develop what's our unique technology, which eventually it's able to operate different data systems and compute systems, and fundamentally is able to bring the analysis and the computation to the data while keeping the data not moving in secure data environments. That's kind of like the background technology of everything that we've developed on top of it. So our board and our investors backed us. By the time we were ready to launch in the market, the world was a completely different world. We became instantly very, very famous and very much in demand. And then ever since, it's been like a really great growth story. And then the next set of challenges has been more like the typical challenges around user experience, faster time to making data usable, faster time to be able to actually connect this data with different analytics, get it into the user hands. But it has been basically all of the expected challenges of growth.
But do you have any competition in the market now?
No, there isn't really someone that is currently providing everything that LifeBit is providing. Of course, there are different point solutions that you would say compete with parts of our offerings, but not really anything in its entirety. And more importantly, no one has really built a proper federated technology that can actually fully compete with LifeBit.
How important do you think is data? Do you think knowing our data as an individual is really going to help with our health and our longevity?
Yes, 100%. So some of our biggest clients and the biggest basically data providers are actually governments. Governments are funded by taxpayer money, and taxpayers are paying for this so that governments can run what's called precision medicine programs, where they can collect data from patients that focuses around rare diseases and complex diseases like cancer. Once we have this data, we will be able to better diagnose these diseases, therefore also create a better treatment. Then they will be able to create better drugs. That is the thesis that currently people are working on. Obviously, that has to do everything with curing the diseases, some of the rarest diseases, some of the most complex diseases currently. Everyone is just generating data at such a great pace, and we are seeing more and more data provider organizations coming into play, and then eventually they want to become data providers. That eventually big part of this data is not going to be used just to cure disease, but also to prevent disease. And I think there is where we are starting then to get into the territories of digital twins, managing your health. And if you see some of the bigger projects that we actually have right now is newborn sequencing. They sequence babies just when they are born. The typical process is we screen babies from anywhere from 5 to 30 diseases, roughly. If we actually do genomic sequencing and if we actually take a more precision medicine approach to it, then we can actually screen babies for 430 diseases.
Wow.
For which we have interventions. Most of these interventions are really supplements like growth hormones or vitamins that if we manage to administer into the babies at the first month of life or couple of months, then the babies might never actually develop the disease, or if they even develop the disease, will have less severity of that disease. So better quality of life, better basically disease progression. As you can understand, if we are now starting to sequence your genome and start collecting data from you from birth, right? The newborn sequencing programs are the first step towards prevention. And there are other initiatives that are aiming to prevention, right? To do prevention, to calculate already in existing patients, even risk factors. And once we are able to do that at full scale, then we will be able to have so much data from you from basically the time you're born that you will have basically a digital twin that will be able to inform how to better manage your life, so that you never develop a disease in the first place. And when it comes to aging, you age, much, much slower. You're able to prevent a lot of the things that create aging in the first place.
When do you see all of this going to happen? Or is that already happening in a certain country?
It is happening. And I would say almost in the next 5 years.
5 years?
Yeah, we should be having far more on the preventative side, not just on the curing side. It used to cost close to $1 billion to actually sequence the first human genome, then hundreds of thousands, then couple of thousands. I used to always give talks and say hey, who here has an iPhone? And I was great, whoever is able to buy an iPhone, then they are able now to sequence their genome. And now is like whoever is able to like buy a couple of drinks, they are able to actually sequence their genome, because the cost right now ranges from $100 to $200. So if you're able to now sequence your genome, then everyone can do it. We will be seeing that people will start doing it ever more. That's one thing. We will start seeing this being more common into the healthcare practice than what it currently is. As I said, the cost of sequencing the human genome is one thing. The second big thing is basically, do you have good methods that are able to collect this data on a daily basis from your watch, from your healthcare records, from whatever it is, and aggregate it? So a technology like LifeBit, but for direct-to-consumer more purposes, then definitely they will need like a technology like LifeBit that will do that.
When you know all those information, what are you going to do with it as an individual if you don't train as a doctor?
There is where you need systems like LifeBit. I mean, there's already a lot of different companies that are direct to consumer that are providing really great insights if you're able to consolidate your data. If we're to do this at the bigger scale, you'll need something as comprehensive as LifeBit is when it comes to kind of like providing all of that information, consolidating the data, making it very usable, integrated, so on and so forth, linking it with the different analytics, right? The same things that we are doing now as LifeBit, but for research purposes, right, needs to be happening for like the everyday individual. So then you come there, and as I said, this concept of a digital twin, you come there and you kind of like almost in real time, you can see what's happening into your health, into your body, and you can just get more recommendations.
I just have a question. So right now, each individual us is a data producer, right? But then who owns that data?
First of all, you own the data. Most of the countries that we work with, very much regulated. They're regulating it even further. All of the regulation is further reinforcing the fact that the ultimate owner of the data is each and every individual, basically. Legislation that is coming in place more and more is providing more and more ability and powers for every individual to decide what they want to do with their data and what should be happening. If you want your data to be used for research purposes, then you can allow that to happen. If you don't want that, you can block that. It will become ever more the standard that each and every individual will own this data, and it will become ever more straightforward for all individuals to be able to decide what happens with its data and be able to actually access and download this data. And then from there, once you downloaded this data, you can very easily think that, there can be an app where you can just instruct and be like, okay, now let's load all of my data to this app and then see what happens. We have the world's largest data network of 270 million patients. Half of that data come from North Americans and the other half from the rest of the world. And it represents more than 80% of all of the diseases that the top 20 pharma are working on. Our mission and goal is to be able to make it even easier, even more straightforward, even more democratized, so that more people can actually use this data, better understand diseases, and then from there, use those understandings to diagnose faster patients, treat better the patients, and then therefore be able to develop better drugs, better diagnostics, pretty much. So that's what we are trying to do. We're doubling down on that. Things that we're especially going to be doing in 25 around AI and that will automate this even further. We'll learn not just from the data, but actually from the thinking and the reasoning and the analytics that people normally perform over this data, so that they can automate kind of like the best experts working with this data, so that then when you use that AI, even if you're not that expert, you can interact with the AI, and then the AI can actually answer your, let's say, research questions using the best scientific methods and research approaches that some of the best experts in the field would actually use, right? And of course, LifeBit has so many insights, right? Like we have some of the best experts. We've been working with everyone in the world. So we kind of like really know what are those type of analytics, what type of like things that questions and how to best answer those questions. So yeah.
And what role you see the AI plays in the future of medicine?
For me, AI, it divides into two categories: AI for automation and AI for discovery. Yeah. I do not think AI for discovery is still here. So basically, AI cannot do what people yet do not know how to do. But AI can do better than humans what humans know how to do. We are mainly focusing on using AI to improve all of the things that we know how to do, we have experience, learn from that, and just do it much, much better, or as great as the best of us, pretty much. So that's what we're going to be using AI in the first phase. And then we will see from there how AI will evolve. Even I would say 95% of the analysis performed over this data have nothing to do with AI or machine learning whatsoever, right?
Yeah.
Very smart algorithm, very smart type of analysis, but not AI or machine learning, right? That might change. We'll see about that. But currently, yeah, most of the analysis still performed are not AI or machine learning related.
What you would say is the biggest misconception towards health, longevity in general that people wouldn't know?
When we talk about prevention, there is going to be potentially a level of anxiety into prevention. Like you will know. And for some of the things that you will know, there might be interventions and things that you can do. And for direct interventions, and for some of the things that you might learn, there might not be interventions, just simply because research is not yet there, right? We just don't, healthcare is not yet there. And I think that is kind of like the biggest thing preventing, I would say, prevention, because there is a resistance to it onto like, oh, well, I know things that I do not know how to act, right? And of course, there are two schools of thought, the ones that really want to know everything, even if they cannot. And then there is those that really are like, I just want to know the things that I can do something about it, because otherwise I'm just going to feel like anxiety. So we are really, really, really hoping that we can speed up the rate of innovation, we can speed up the rate by which we're learning from this data, so that eventually for everything pretty much that, we learn, there is something we can do, right? Definitely when it comes to longevity, I don't believe that there's going to be one pill that all of a sudden is just going to make us younger, right? Why? Because we are systems, right? Yeah. And systems tend to be also influenced by their environment, right? So eventually you'll need to having something that collects enough data to be able to tell you what is effectively affecting your longevity, right? Is it the different environmental stressors? Is it your food? Is it your sleep? So it's kind of like a complex system for which I think if you really want to do a good management of longevity, then you need data.
What will be the good process for me to collect my data and utilize those data?
I would always advise everyone to sequence their genome. Just doing that and seeing kind of like your predispositions and risk factors. I always joke with people because people tell me, oh, I hope like this is going to be very exciting. I'm like, no. I'm like, you should be wishing this to be very, very boring. Because exciting is not a good thing to have a very exciting genome. Because a very exciting genome is like we're finding some like rare gene, predisposition, So very boring means basically you are just like, if you are normal or you are like, we're like average. So we don't see anything like extraordinary with your genes, right? It's good to sequence the genome as young as possible. So if and when you get that disease, then you can do a post-genomic sequencing, and then you can compare and contrast kind of like your genome when you were kind of like pre-disease and post-disease, as we like to say, right? And that gives you already a lot of data. And then if you give this data, then if, for example, you get the disease, then you can actually give this data to whichever healthcare system or provider is managing your health. And then that will definitely give you better diagnostic and just a better prognostic and disease management journey. So that's from the disease perspective. From the preventative perspective, I think getting insights into your genome and different kind of like predispositions, risk factors, it will be just like very telling in different ways, right? If you are a slow metabolizer, like it will just help with just different things to just be able to just like really, really understand and then use that information.
Let's say in the future, when the digital twins do come around and we do have a really amazing AI assistant to tell us what we should do. Let's say maybe after knowing all my data and all my measurement, where you see the ethical between relationship between human and machine? Is technology really make our life better and healthier?
Yes, 100%. I mean, if you just think the history of healthcare, we used to have almost like a random way of treating, right? Like it was almost like someone had observed that this plant, had some effects, and they were just like giving you this plant. It was completely observational. And then we moved into what has now become the prevalent healthcare system, which is symptom-based. Whenever you go to the doctor, what does the doctor ask you? How are you feeling? Are you coughing? Do you have headache? Have you been having like fever? All of your symptoms pretty much, right? And we do a collection of symptoms. But the next thing that we want to be moving is that you go through some sort of like quick scanner, and then we're able to very, very quickly, and especially if we have already a lot of information about you, to generate a bunch of data and tell you what to do. And this is moving healthcare pretty much from symptom-based to data-based. A lot of our healthcare system is not just symptom-based, right? There's a lot of data. Like, no one will give you a diagnosis of cancer if they don't pass you through a bunch of different like lab tests. Those are data. We are using data already. So it's not that our like healthcare system is purely symptom-based, but I see a future where it will become predominantly data-based and almost not at all symptom-based. So that's one big shift. The other big shift is right now our system is generic, right? So on that generalization, we also give you a pill that is supposed to work the same for you as it's supposed to work for me and everyone else on planet Earth. Well, that's not the truth. In fact, a lot of the pills do not work the same. There is many also differences between men and women simply because we're just different. There is many differences in actually between different ethnical backgrounds because the genetics are completely different. So we already know that the one pill fits all doesn't work.
Yeah.
So the second big shift as we're moving to data-driven healthcare is moving to more precise first and then more personalized, so that you go to a doctor and very quickly we're able to generate a bunch of data that will able to give us a diagnosis, a proper diagnosis for you. But then on the base of that, very quickly manufacture a drug that's going to be tailored for you.
Yeah.
And that's pretty much where the entire world is trying to go. And I think that's a good thing. And companies like LifeBit have definitely by now set a very clear example that the only danger is if you're not the controller of your data.
Yeah.
And if there are unauthorized uses of your data without your consent. Really, that's the only danger. I understand that there might be the psychological effect of do I need to know everything? But beyond that, there is really no other danger beyond are you the sole controller of this data and are there any unauthorized uses of this data, right?
Yeah.
And technologies like LifeBit, I mean, the entire existence of LifeBit has proven that there is definitely technology and technical capability that can guarantee for a fact that they can keep the data where the data is designated to be, and then they can ensure that the controllers of the data are always in control and that there are no unauthorized uses of this data, right? And if anything happens to the data, it's properly recorded and then you're able to react to it and so on and so forth, right? I personally do not see any dangers around it. I only see benefits.
Okay.
Moving forward.
What will be the best way, let's say, for me as an individual to collect the data day to day? Are they according to age, or should we just get a whole body health check?
If we take the more disease treatment approach, right, we would say that if there are no like big risk factors in your family, there is no real big reason to try to just collect a bunch of this data, right? Now, if you want to take the more preventative approach, then my opinion would be collect as many data as soon as possible, right? The first thing, as I said, I would do whole genome sequencing, right? So you can understand your genome and you can get this data and save it somewhere. And then, as I said, you can use this data because your genome is not that changes every time. But if you get cancer or if you get into other type of diseases, then having your genome pre-disease and then doing another whole genome sequencing post-disease, then that allows us to compare. And then that comparison allows us to say if there has been some genetic mutation that has led to the disease or something has happened, and then we will be able to, by identifying the cause of the disease, assuming there are genetic factors to it, right, then we will be able to better treat it. And that's mainly applicable for cancer, but not just for cancer, right? The second thing to do is, as you said, every time you go to the healthcare, you can download your data. So you still can download your data if you want and just like collect it somewhere, right? And again, not use it up until you need to use it. And yeah, and from a prevention perspective, there are so many different, as I said, companies out there now that can give you really good risk factors, predispositions to different things that are not necessarily diseases, that just getting some of these insights, you can do a lot of lifestyle, if you like, and environmental changes to help everything your longevity, your well-being, your energy levels, your health.
For you, what is aging? Is aging a disease?
The strict definition, the initial definition of a disease, the definition that used to say that if a bacteria is pretty much contaminated your body, then you are, in disease. I think by now we have expanded the terminology of a disease, right? So everything that is making us not be healthy, that's therefore a disease, right? So if we take that broader definition of a disease, which, as I said, is not the quite strict scientific definition of a disease, then yes, aging can be then classified as a disease, right? Because it's keeping you not in a healthy state. But it's more and more becoming abundantly clear that disease is basically a molecular clock. At some point, post the reproductive age, for both men and women, the body has a switch that basically says this being has fulfilled its purpose, so now we can actually start eliminating them. And there has been some studies looking back at many different organisms, right? And actually starting to realize that there is that molecular clock that pretty much at some point there is literally a signal that says this body has fulfilled this purpose. We're ready to discard it pretty much. And that's then what starts that aging process. Having that understanding, then it means that we will eventually much better be able to intervene into that. Because if a molecular clock, we can reverse molecular clocks. And there are also other studies that are starting to show that there is a particular class of proteins. They act like rescue proteins, where they come and they fix your cells, right, in order for your cells to regenerate. And those class of proteins, once we have that molecular switch to aging, then they start basically being underexpressed. What does that mean? It means that your cells do not renew as much, right?
Okay.
So they keep aging and aging. So you're not really aging because you have cells that go bad. You're aging because the cells that go bad are not being fixed, basically.
Yeah.
So then you accumulate more and more basically dysfunctional and, if you like, broken cells, right? Or what we call aging cells. So, and that's very, very high level descriptions of it. But this seems to be where we currently understanding of what's happening now with what we call aging. So that gives me hope, because if it's not hard coded into our gene and it has to do with the expression of our genes, then that is about 1 million times easier for us to intervene and correct. Over also the next 5 years, there's going to be something around aging as well. But as I said before, aging will always be influenced by all of your environmental factors and all of your different genetic predisposition. So there's no escape from that. So it needs to be a joint effort between doing more preventative and better well-being and health management, and at the same time having some very specific interventions that will be able to, if you reverse our molecular clocks, or whatever is happening with our molecular clocks, we age slower or we age at a later point.
And if you could give our audience one tips in longevity or health overall, what will be your one tip that people can actually apply to their day-to-day life?
It's all about autophagy, so that I'm sure I'm not the only person saying this in the show. So autophagy is the mechanism. I like to call it the garbage collector. So autophagy comes and just degrades broken cells, and then pretty much then helps regenerate them or actually really recycle broken and bad cells and put the pieces back into circulation so that new cells can actually be created. And I like the example of a garbage collector because it's think of a city, right? And think that city has particular people and energy, right? So capacity. And if now that city is busy throwing a party or doing other things, then they will not be able to have these people to go and just deal with the garbage. But pretty much what we need to be doing is you need to be giving time to your body for the garbage collector, for autophagy to be activated. When does that happen? When does your body get that time? When you sleep, when you train, and when you stop eating. Digestion consumes by far the biggest amount of energy, right? And that only makes sense because if we do not, our bodies do not digest food very fast, then the food will ferment. In ferment, then you get intoxication, you die. So your body always need to make sure that, does food processing in real time and as fast as possible. So whenever we give break from food, right? And we don't need to fast for I've heard everything, water fasting for 5-20 days. We don't need these extremes, but eating within 6 to 8 hour windows, so giving enough time for our body on a daily basis to just like rest and allow autophagy to kick in. Exercising helps autophagy, sleeping helps autophagy, right? Those are the typical things.
For you, what is your health habits towards your mental health?
First of all, you need to have good energy levels. I like to see energy level as a finite, like money or capacity. So you need to really, really understand how your body is using its energy. And if you have finite energy, how would you use it? When I wake up, I tend to not skip breakfast. So that basically gives me a lot of like energy because I'm like still fasting. I will most probably go to the gym, have a bunch of water, but I'll still not eat up until 12 or 1 o'clock. My first meal is normally going to be just pure protein, so just a couple of eggs. Protein really, really helps to kind of like give clean energy. And during my lunch break, I tend to not eat much. So during lunch, I will try to have salad or some fruits, something that's going to be on the lighter side. Definitely, I will avoid carbs. So that's something that's easy for my body to digest. And really, it's only going to be like my dinner. I try to have like, about 2 or maybe like 3 meals a day within a 6-hour window or 8-hour window. And then it's only kind of like during my dinner that normally is going to be around 5-6 o'clock. If I am to eat carbs, I'll eat at that point, right? What that means, it means that I have energy. Like I have really, really great levels of energy. And whenever I feel that my energy is slightly going down, then that normally because actually your brain requires a lot of glucose. So then I'll try to eat some fruits. Basically, I'll just snack on some like fruits. And then that's pretty much it. But if you do that consistently and also if you train, then you will definitely have energy levels and you will not feel as tired, right? No matter your age. And of course, then supplementation on top of that really, really helps with different vitamins and different other supplements.
What is your driving force?
I just like what I do. And I think there is much to be done. I'm only the leader if I'm working with the leaders. We are working with literally the leading projects across the world. Public sector, private sector, non-for-profit organizations. It's just incredible the things that our clients are doing. And we're just very privileged and honored to just be working with them and helping them to do the things that they're already doing, just much faster, much better, basically. I'm just really, really passionate about the space. We are definitely in the biotech revolution. We're really discovering this new universe, not just conquer the world, but like conquer ourselves, really understand ourselves, right? And that just fascinates me, as I said, and the discoveries and the impact that they have, like, when you're working with projects that they are sequencing babies to ensure that, we're able to treat babies that will have rare conditions or hereditary conditions even, can try to intervene however we can. Then we were working like with cancer projects. We are working with autoimmune diseases. And when we're seeing the impact that is happening across the world, it's just very inspiring.
Where do you see the healthcare heading to in the future 10 years?
There is a lot of innovation that is coming, especially in precision medicine. And what's going to happen with precision medicine? As I said, it's going to become data-driven, more and more data-driven. And that is a good thing. Basically, we're going to have more robotic system, AI systems that will speed up the diagnosis, the interventions, the surgeries that we do, everything pretty much. And that, again, is a really good thing. So I'm definitely excited about what's going to happen. We're going to be seeing some like huge changes over the next 5 years around how things are moving. And then even beyond these 5 years, it remains to be seen. I almost cannot like predict where we're going to be at that point.
Thank you very much, Maria, for today's episode.
Thank you so much, Méline.
Thank you for watching the HumanWare project. To help us to getting more amazing content out there, please subscribe. It means a lot and it will help us to grow. And let's go on this journey together.